Welcome all. Now we are going to explain the principle of flame photometry. As we all know, whenever any sample salt solution is introduced into the flame, the solvent is vaporized, leaving behind tiny particles of solid molecules, which further on heating are converted into gaseous molecules. These gaseous molecules are then decomposed into the gaseous atoms. Some of the gaseous metallic atoms absorb the heat energy from flame and got excited. The transition of the atoms takes place to higher energy state. These atoms return to the ground state by emitting the radiations. If we know the amount of radiations emitted and the wavelength of the emitted radiation, we can have quantitative and qualitative analysis. So, coming to a brief overview of the process, the solvent is first evaporated, leaving fine divided solid particles. And these solid particles move towards the flame, where the gaseous atoms and ions are produced. The ions absorb the energy from the flame and get excited to higher energy levels. And when the atoms return to the ground state, the radiation of the characteristic element is emitted. And the intensity of emitted light is related to the concentration of the element. For this, the temperature of the flame must be 2000 degree Kelvin or above, and the fraction of number of the atoms which are excited is given by the Boltzmann equation N1 by N0 equal to AE of delta E by KT, where N1 is equal to the number of the atoms in the excited state and N0 is equal to number of the atoms in the ground state, where delta E is the energy of activation and K, which is the Boltzmann constant, and T, which is the temperature in Kelvin, and A, which is the characteristic constant. So that's all, and hope it was helpful. Thank you.